Boy, that was an abrupt ending on part 2, huh? Sorry about that. So what I'm doing is I'm trying to show you how picking this m is going to actually give me that tm minus Sn is less than epsilon over 2. And so what does this look like over here? My capital N in this example is 4. A little m bigger than or equal to big M is, let's just pick 7. So what's this going to look like? This is going to look like, well, T7 is equal to A6 plus A3 plus A1. I'm just counting them up from here. A4, A9, A2. A9 plus A2 plus, can I even read that? I believe that's A5. Barely legible. Minus my S4. My S4 is just going to be A1 plus A2 plus A3 plus A4 equals, well, again, we get to do some nice cancellation here, right? A1 is going to cancel with A1. A2 is going to cancel with A2. A3 is going to cancel with A3. A4 is going to cancel with A4. And I picked my big M exactly so all of these things are going to cancel out. That's the power of the big M. It makes all the unwieldy things cancel out. A6, I'm left with A6, A9, A5. A6 plus A9 plus A5. Oh, I can use a triangle inequality here to get A6 absolute value plus A9 absolute value plus A5 absolute value. Well, what does this look like? This looks a lot like the partial sums of this. So, how do we make this look? Right, this is going to look, the tough part and part why it's difficult to understand is that notation here gets kind of weird because you're missing a whole bunch of terms. You're not quite sure what that's going to be. But this is going to be, this is going to equal b sub 1 plus b sub m minus a sub 1 plus a sub n. Now, the important thing here is, and this is going to cancel out to give you, I don't know, how about b sub j sub 1 plus da 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 plus b sub j sub, this is ugly, m minus n. You get a whole bunch of b's, right? Over here, everything of these a's canceled out. That's exactly what's going to happen over here. So you get a whole bunch of these b's left over. And in particular, these b's are just rearrangements of the original a. So you get, I don't know, this is getting uglier. A sub k sub 1 plus da 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 plus a sub k sub m minus n. And the important thing here is that all terms, all the k sub I are bigger than or equal to n. Why is that? Because I made sure that my m was big enough that I was going to cancel out. It's going to have something to cancel out with all of these small ones here. So I made sure that I went up far enough to get 1, 2, 3, 4 in this case. And so what I can do is then I can look at this. I can use the triangle inequality to get that this is less than or equal to a sub k sub 1 plus da, 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 plus the absolute value of a sub k sub m minus n. Horrible notation, way too many subscripts, but that's the price you pay for understanding, I guess. And then, look, now we get to go back to our n2. This thing converges, so whenever we have m plus 1 up to a sub n, that's less than epsilon over 2. So that's going to be less than or equal to a sub k sub 1 plus a sub k sub 1 plus 1, the next term, plus da da da